Hi, today we're going to learn about molecules. In order for you to answer these first few questions here on slide 2, you need to be able to watch this video. So we're going to watch this video real quick.
What's the difference between an atom and a molecule? If you're wondering this, you're definitely not alone. This is such a common question in chemistry. So the short answer is atoms are like Legos, blocks, bricks, and molecules are like the stuff that we actually build with those blocks and bricks. That's the short answer. Let me give you a longer answer. That might be more useful. So let's start by talking a little bit about atoms. There are a few important parts. An atom has a nucleus, which is made up of protons and neutrons. That's what I'm drawing here with little dots. And then around the nucleus of the atom, that's where electrons live. And electrons live in these circular neighborhoods called energy levels. And so I'm drawing in the electrons here with these black dots. Many atoms have more than one energy level. So they have these rings kind of around the nucleus like this with these electrons. Okay, so here's one. Let me draw another. Here's a proton. Here's a neutron. This atom is going to have one proton. And then around the nucleus, here's an electron. Here's an energy level where one electron is. Okay, so two atoms here. So there are all sorts of different types of atoms. And the type of atom that you have depends on the number of protons in the nucleus. This atom over here has 8 protons in the nucleus, which means that it is this one over here, which means that it is an atom of hydrogen. As I said, they're all different kinds of atoms, and they're actually about 100 different kinds. And when we talk about them, it's usually easier than sort of like writing out the name every time. We use abbreviations. So when we talk about oxygen, you write it out. For hydrogen, there's an H. We have carbon atoms represented by a C. We have nitrogen atoms represented by an N. Chlorine with a Cl. Fluorine with an F. And so on and so on. All of these atoms, all these types of atoms, are all a little bit different. I like to think about these like Lego blocks, right? There are all these different types of Lego blocks, but they're all a little bit different. They're different colors, they're different sizes. Some are tall, others are like flat and skinny. And that's like these atoms that all have slightly different characteristics. Now, the different characteristics of these Lego blocks come in handy when we actually want to build something. And then we're happy that, one is really skinny or one is red or whatever. And so that's where the different qualities of the atoms come into play. We take these bricks and build like a little house. And now we're talking about molecules. So we take these bricks and we snap them together. We can do the same thing with atoms. I can take an oxygen atom and snap it together with 2 hydrogen atoms. And when I say snap it together, I mean I physically connect it. That's these little lines here. And when I do that, when I have 1 oxygen connected to 2 hydrogens, I have a molecule of water. I call it H2O because there are 2 hydrogens and 1 oxygen. Or I can do this. I can take a carbon atom, snap 3 hydrogens to it, attach another carbon with 2 hydrogens, and then an oxygen, and then a hydrogen, and I have a molecule of ethanol, which is a kind of alcohol that's in beer and wine. So the point is, molecules are made when we take individual atoms and physically combine them together to make stuff. Just the same way we take individual Lego blocks and snap them together to build houses or whatever you want to make. Now I'll even take this one step further. I showed at the beginning that if we could zoom in zones and zones of time, this is what an atom would look like. If we took this water molecule and we could zoom in on it zones of times, this is what we'd see. And we'd see the oxygen atom and the 2 hydrogen atoms, and that they're actually physically
All right, so now that we know the difference between atoms and molecules, we're going to come in here and we're going to answer the questions. What is the difference between atoms and molecules? How does the instructor compare atoms and molecules to Lego blocks? Describe what molecule of water looks like. How many atoms are there? Are the atoms combined together, and how? Right here, we're going to read this, then you're going to tell me what a molecule, a compound, and a chemical formula is. Imagine you're drinking a glass of water. It looks clear, tastes refreshing, and keeps your body functioning properly. But what is the water really? At the most basic level, water is made up of atoms, the smallest building blocks of matter. We know that atoms themselves are composed of even smaller particles called protons, neutrons, and electrons. The number of protons an atom has determines its identity, and its electrons affect how it interacts with other atoms. Water is composed in two specific types of atoms, hydrogen and oxygen. When two hydrogen atoms bond with one oxygen atom, a water molecule is formed. A molecule is any group of two or more atoms chemically bonded together. These molecules are very, very small, and in fact, a single drop of water contains that much water molecules. Whenever a molecule has just one type of atom, we call it an element. Hydrogen and oxygen are both elements. Water is a compound. Every molecule in a compound contains at least two different types of atoms in it. There are many other compounds you probably know of already. Table salt, baking soda, dry ice, and rust, to name a few. Each of these substances contain a different combination of atoms. Scientists name molecules by their chemical formula. You know the water's chemical formula already, H2O. This formula means that for every molecule of water contains two atoms of hydrogen and one atom of oxygen. The little 2 in the formula is a subscript. This shows how many atoms, H atoms, there are in every molecule. Now, right here, you're going to tell me what a subscript is and what a coefficient is. What if there's no subscript, like an O? This means there's just one of that atom. Sometimes chemical formulas can look complicated. For example, granulated sugar you probably have in your kitchen is a compound of chemical formula of C12, H22, and O11. Following the subscript rule, we know this really means that each molecule of sugar contains 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Sometimes scientists also use structural formulas to show how atoms are arranged in a molecule. The structural formula for water is HOH. This shows how each atom is bonded to the oxygen atom in the center. However, this method is not as easy as just using chemical formulas. Finally, chemical formulas can also show how many molecules we have. What do you think the chemical formula for 5H2O means? The big 5 is the beginning of a coefficient. Coefficients always tell how many molecules we have. In this case, there are 5 molecules of H2O. Another example is 6CO2. This is, in this case, 6 molecules of carbon dioxide. This means that we have 6 atoms of carbon. We calculate this by taking the big 6 multiplied by the 1 we assume for carbon. There are 12 atoms of oxygen because we multiply 6 by 2, which means there's a total of 18 atoms present. Molecules and compounds are essential to your everyday life. As you learn about how atoms are grouped together, think about all the ways you benefit from chemistry. Right here, you're going to read these and you're going to answer the questions. CH4 is an example of a compound, element, atom, or subscript. How many molecules are present in the formula? 2 plus 4 is what? Which of the following statements about molecules are true? All molecules contain two or more different atoms. Molecules contain two or more atoms chemically bonded together. Molecules are a type of compound. Chemical formulas do not give information about the structure or composition of a molecule. Right here, you're going to count your molecules and you're going to decide which one is which, CH4, H2O, or H2O2. When more than one atom is combined together, they are called molecules. Right here, you're going to use these components and you're going to build your own molecule of SO4, and then your coefficient of this chemical is going to be 2SO4. So you're going to build 2 SO4s. Look at the model you created. How many total atoms of sulfur are there? How many total atoms of oxygen are there? How many total molecules are there? And how many total atoms are there? Now you're going to take and match up the formula to what you see here in the pictures. Now on our last slide, we are going to use our word bank and we're going to put these in the right places. When more than one atom combines, it creates a blank. To give them a name, scientists use a blank. One example is H2O. It's considered a blank because it is composed of two different atoms, hydrogen and oxygen. If you're looking at this formula, then 2 is the blank. What if you had more than one molecule of water? To demonstrate this, you would add a blank, like the formula of 4H2O. If you have any questions, feel free to ask.